Hello guys, welcome back. This is problem set 7 of the lecture series Signals and Systems. So in this video, we'll be solving some questions on LTI discrete time systems. So let's get started. So coming to the first question, let x of n equal to delta of n plus 2 delta of n minus 1 minus delta of n minus 3 and h of n equal to 2 delta of n plus 1 plus 2 delta of n minus 1. Compute and plot each of the following convolutions. Okay, so first subpart is y1 of n equal to x of n convolved with h of n. So let us first try to visualize how x of n and h of n look by plotting a graph. So x of n versus n. So at 0 it is delta of n and 2 delta of n minus 1 and minus delta of n minus 3, which means at 2 it is 0 and at 3 it is minus 1 and everywhere it is going to be 0. So this is our x of n, and how does our h of n look like? So 2 delta of n plus 1, so minus 1, 2, 0 and 2 delta of n plus 1. So this is our h of n. So first subpart, they have asked us to find y of n equal to x of n convolved with h of n. So how do we convolve? We find x of k, which is nothing but this x of n itself, just the replacement of the variable n with k. And we need to find h of n minus k. So we have to take the reverse of this and then shift it to the right by n units, right? And what is this summing coefficient? So k equal to minus infinity to infinity. So let us try to find h of n minus k. So h of minus k, how will it look like? So it will be same because this is a even symmetric signal, right? So it will be 2 and 2 here. And if I have to get h of n minus k, I have to just shift this to n and n, right? So this will be my h of n minus k. And I can find for each y of n. So first, considering if my n plus 1 is less than 0, then there is no overlap, which will imply my y of n is equal to 0 for n less than minus 1. And if n minus 1 is greater than 3, still my y of n will be equal to 0 because there is no overlap, and my n will be greater than 4. So I need to find values of 0, 1, 2 and 3, right? So what will my y of 0 be? So if you try to overlap this with this, I will get, let me first h of minus k. So I'll have minus 1, 2 and 2 and 1, and my x of n is nothing but 1, 2, 0 and minus 1. Okay, so this is my x of k. So now I can find y of 0 is nothing but this exact multiplication and then summing up. So you can see there is only one overlap, 0, 1, 2, 3 at 1. So 2 into 2 you will get 4, right? So my y of 0 will be 4. Okay, and again y of n is 0 for n less than minus 1 and n greater than 4, which means n equal to minus 1 and 4 are also included. So we'll start with, let's say, okay, we already found y of 0. We'll try to find y of minus 1. Y of minus 1, you have to shift this to left by 1. So then you will have overlap. This 1 will come to 0. So at 0, you will be having a 2. Here you have 1. When you multiply, only that term will remain. So this will be equal to 2. And what about your y of 1? You have to shift this to right. So your y will come, your h will become like this. And you will have overlap only at origin, 0. Again, it will be So your y of 1 is equal to 2. And what about your y of 2? So y of 2, you have to push this to the right by 2 units. You'll get at 1 and 3. So 2 and 2. So what overlap you will have? At 1 you will have 2 into 2 plus at 3 you will have 2 into minus 1. So you'll have 4 minus 2 equal to 2. So your y of 2 is also 2. And what about your y of 3? So your y of 3 you will have, this is your h of minus k. You will have at 2 and 4. But if you see here 2 and 4, it is 0. So your y of 3 is going to be equal to 0. And finally, we'll calculate y of 4. So y of 4, this is going to be at 3 and 5. So 3 and 5. At 5, this is going to be 0. At 3, this is minus 1. So 2 into minus 1 will give me minus 2. Okay. So this is how you keep shifting this h of minus k. And then you take the product and then you can find each of the values of y of n. So how you can represent this? So you have 2 delta of n plus 1 plus 4 delta of n plus 2 delta of n minus 1 plus 2 delta of n minus 2 and minus 2 delta of n minus 4. Okay, so this will be your answer. There is also another simpler way to do it. So let us take this. And this will be very helpful to convolve the delta functions. So your x of n convolved with h of n is nothing but delta of n plus 2 delta of n minus 1 minus delta of n minus 3 convolved with 2 delta of n plus 1 plus 2 delta of n minus 1. So you can use the distributive property. So you will get this going with this and this, and then this going with this and this, and then this going with this and this. So we'll get 6 terms. Okay. So let me calculate the first 2 terms. So delta of n convolved with 2 delta of n plus 1. So you know that delta of n convolved with anything will be that same thing. So 2 delta of n plus 1 plus 2 delta of n minus 1 plus, now 2 delta of n minus 1 convolved with 2 delta of n plus 1. So this minus 1 and plus 1 will cancel and it will be 4 delta of n. And 2 delta of n minus 1 plus 2 delta of n minus 1 will give me 4 delta of n minus 2. Right? And then last 2 will be minus delta of n minus 3 and delta of n plus 1 will give me delta of n minus 2. So 2 delta of n minus 2 and minus n minus 3 n minus 1 will give me 2 delta of n minus 4. Why? Because this is already at 1 and this convolution will push this to the right by 3 units. So it will come at 4, right? So that is how you can just add these terms and then write it down. So convolution of delta functions are very easy. I'll write it down here. Delta of n minus n naught convolved with delta of n minus m naught is equal to delta of n minus n naught minus m naught. Okay, so now you can simplify this. So your delta of, you have 1 delta of n plus 1 term and 4 delta of n. Delta of n minus 1, you have only 1, 2 delta of n minus 1. And delta of n minus 2, you have plus 2 delta of n minus 2. And you have minus 2 delta of n minus 4. So if you compare this with this, you're seeing the results are matching. Okay. So let us take a look at B and C subpart. So B, we have x of n plus 2 convolved with h of n. So B, y2 of n is equal to x of n plus 2 convolved with h of n. So again for this, once you know this result, you needn't again get this result by drawing graph or multiplying this and everything. This you can simply write it as delta of n plus 2 convolved with x of n convolved with h of n, right? Because you can write your x of n plus 2 as delta of n plus 2 convolved with x of n, right? And you can use the associativity property and write it as delta of n plus 2 convolved with x of n convolved with h of n. And this is nothing but delta of n plus 2 convolved with y1 of n, which is nothing but y1 of n plus 2. So you can just replace n with n plus 2. You will get 2 delta of n plus 3 plus 4 delta of n plus 2 plus 2 delta of n plus 1 plus 2 delta of n minus 2 delta of n minus 2. Similarly, for this one also you can do using the same method. So what we want, see, your y3 of n is equal to x of n convolved with h of n plus 2. This is nothing but x of n convolved with h of n convolved with delta of n plus 2. And this is going to be x of n convolved with h of n convolved with delta of n plus 2. And this is nothing but your y1 of n convolved with delta of n plus 2. And this is going to be equal to your y2 of n. So you can just copy it down. Delta of n minus 2 delta of n minus 2. Okay. So this is how you can easily work with convolution when you have all unit impulses. Okay. So now let us move on to next question. So once you are computed, you can also plot it. It's easy. You just have y of n, you can plot it. Okay. So second question. Let x of n equal to 1 from 0 for n from 0 to 9 and 0 elsewhere, and h of n equal to 1 for 0 less than or equal to n less than or equal to n and 0 elsewhere, where n is less than or equal to 9 is an integer. Determine the value of n given that y of n is equal to x of n convolved with h of n, and y of 4 is given as 5 and y of 14 is given as 0. So you can see both are like square pulse kind of functions, right? So let us try to plot them. So we have 1, 1, 1 and so on up to 9, 0 to 9. So 10 units total. N, and you have h of n given by 1, 1, 1 and up to n, 0, 1, 2, 2 n. Okay, n. Now y of n is nothing but x of n convolved with h of n. So when we convolve two square pulses or something like that, let's see what happens. So I'll take my h of n minus k. How versus k? How will this look like? So my minus k will start from minus n minus 1 and so on, right? And I'll have minus 2, minus 1 and 0. This is my h of n minus k, and if I have to get n minus k, I just put n here. So n minus 1 and this will be n. So now I can see where will the overlap come. So you can see for n less than 0, there is no overlap. So your y of n equal to 0. And for n minus n greater than 9, which implies that n is greater than 9 plus n, again no overlap. And your y of n is again equal to 0. So which means that if two, so it need not necessarily be square pulse because it is true regardless of anything, right? So we haven't brought this amplitude into picture. So if two signals have extent 0 less than n less than n1 and 0 less than n less than n2, then their convolution will have an extent. Extent meaning I'm saying it is non-zero. So it will be at most, right? So in between, if they can also get cancelled if there are even number of terms and we have 1 minus 1, each of them cancelling out, then it is possible that they cancel. But at most, this is possible that the convolution will have 0 less than n less than n1 plus n2, correct? So if the first signal has n1 plus 1 samples and second signal has n2 plus 1 samples, the convolution will have n1 plus n2 plus 1 sample, correct? Okay. So now let us see what they have given. So x of n is from 0 to 9 and h of n is from 0 to n. So y of n should can at most be non-zero in the range 0 less than n plus 9. But what they have given, y of 14 is equal to 0. So y of 14 equal to 0 implies that, so if I take 0 less than 14 less than n plus 1, in this region it is equal to 0, but not equal to 0, and I want equal to 0, meaning your 14 should be greater than this range, right? So your n should be less than 5, correct? Which means n can take values 0, 1, 2, 3, 4 up to 4. Anyway, 0 is not possible. Why? Because your y of 4 is given as some positive value. If h of n is all 0 signal, your convolution will anyway be 0. So now let us use this y of 4 equal to 5. So what you have, y of 4, how will you calculate? You should shift this by 4 units. So you will have 1, 2, 3, 4 and 0, 1, 2, 3, 4, and you will have 5 of them overlapping, correct? So let me draw it again separately. Okay. So this is my x of n. And I have 1, 1 up to 9. And I want h of 4 minus k. Let me call it k. And I know my n is only from 0, 1, 2, 3 or 4, right? But at least if I say it is 1, where will it start from? It will start from 4, correct? And I want the overlap such that their product, and then while taking the sum, it should be equal to 5. So let me check one by one. So if n is equal to 1, what you will get? You will get y of 4 equal to 1, correct? Only one overlap. If n is equal to 2, so first is n. So we should also include n equal to 0, because n equal to 0, here they have given less than or equal to. So that means that there will be at least one signal with one sample with 1. So let's check for n equal to 0 also. So n equal to 0 meaning it will be present only at the origin. So here y of 4 will be equal to 1. And n equal to 1 meaning 0 and 1 it will be present. So your y of 4 will be equal to 2. And at n equal to 2, you will have y of 4 equal to 3. And n equal to 3, you will have y of 4 equal to 4, because you will have 4 samples. And n equal to 4 only, you will have y of 4 equal to 5. So which means that your n should be equal to 4. And this is also possible when your h of n is something like this, correct? Something like this. It can have many samples, and if only 5 of them are overlapping, it is also possible. So this y of 14 equal to 0 is restricting your n to less than 5. And then using the second condition of y of 4 equal to 5, we got that your n is equal to 4. So that is what they have asked to find. So your answer is n is equal to 4. So let us look at question 3. For each of the following statements, determine whether it is true or false. So if x of n is equal to 0 for n less than n1 and h of n is equal to 0 for n less than n2, then x of n convolved with h of n is equal to 0 for n less than n1 plus n2. So is it true or false? Let us try to check. So your I'll write it directly as x of k is 0 for n less than n1. So let me take n1 as somewhere here. So from n1 it can have non-zero samples, and less than n1 it is going to be equal to 0. And your h of k, it's equal to 0 for n less than n2. So some n2, below that it is going to be equal to 0, right? So now let me find h of n minus k. What will happen? Where will my sample start from? It will start from n minus n2 and it will have a left tail. So now I need to find the non-overlap case. So where are they non-overlapping? My n minus n2, if it is less than n1, then there is no overlap. And your convolution will be equal to 0, which means that n is less than n1 plus n2. Your convolution is going to be equal to 0. So that is what they are also given. So it is true. So the B part, what they have given, if y of n is equal to x of n convolved with h of n, then y of n minus 1 is equal to x of n minus 1 convolved with h of n minus 1. So what do you think? Is it true or not? So let me write it down. So you may think that to replace it, if I replace the left hand side n with n minus 1, then right hand side also I am replacing n with n minus 1 in both case. But actually that is not the case. Your y of n minus 1 should take place only by replacing one of them. Either this or x of n convolved with h of n minus 1. This is because this is just a way of representation. In reality, we should write something like x convolved with h of n, something like this. Then it will make a lot of sense. But this is just a way of representation. You cannot directly substitute n with n minus 1. So your y of n minus 1 is nothing but your y of n convolved with delta of n minus 1, correct? Which is equal to either x of n minus 1 convolved with h of 1 or the otherwise, right? So what happens when you do this? So this is nothing but x of n convolved with delta of n minus 1 convolved with h of n convolved with delta of n minus 1, which means that this is nothing but x of n convolved with h of n convolved with delta of n minus 2. So this is going to be equal to y of n minus 2 and not y of n minus 1. So that is why this is going to be false. So you should always remember that it is only a way of representation we are doing this. It is not in reality you have to substitute both with n minus 1. Okay? Because the actual operation of convolution itself, summation n equal to minus infinity to infinity or k equal to minus infinity to infinity, x of k, h of n minus k. So now in this operation, it is mathematically true and you can substitute n with n minus 1. But this is just for the representation case. There is no mathematics involved here. Okay? So that is all with this question. So coming to the fourth question. Consider a causal LTI system whose input x of n and output y of n are related by the difference equation. Y of n is equal to 1 by 4 y of n minus 1 plus x of n. Determine y of n if x of n is equal to delta of n minus 1. So they haven't given anything about the initial condition, so we can assume initial rest. So my x of n is equal to 0 for n less than 1 because I have it only at starting from delta of n minus 1. So this implies that my y of n is also equal to 0 for n less than 1. So now I have to find y of 1. So y of 1 is nothing but 1 by 4 into 0, which is y of 0 is 0, plus x of 1. X of 1 is going to be equal to 1, right? So x of 1, this is going to be equal to 0 plus 1 equal to 1. So then I can do it recursively. So 1 by 4 y of 1 plus x of 2. My x of 2 is 0, right? So I'll get 1 by 4. Similarly, y of 3 onwards, it will be 1 by 4 y of 2 plus x of 3. Again, this is 0. It's going to be 1 by 4 square. So and so on. At y of n, what will I get? I'll get 1 by 4 y of n minus 1 plus x of n. This is anyway 0. So I'll get 1 by 4 y of n minus 1. So what will be my y of n minus 1 be? So if you see here, my y of 2 was 1 by 4. So y of n minus 1 will be, so 1 by 4 power 2 minus 1. So y of n minus 1 will be 1 by 4 power n minus 1 minus 1. It will be 1 by 4 power n minus 2. So in similarly, you can tell y of n is nothing but 1 by 4 power n minus 1. Again, it is starting only from y of 1. So what can you write your y of n as totally? This is for n greater than or equal to 1. So it will be 1 by 4 power n minus 1 y of u of n minus 1. Okay. You can just represent it with the unit step function with one right shift. So that's all right in this question. Okay. So let us move on to the next question. Consider the cascade of the following two systems, S1 and S2. Okay, you have x of n giving w of n passing through S1, and S2 is giving y of n. And S1 is given as causal LTI, and the relationship is given here. W of n is equal to 1 by 2 w of n minus 1 plus x of n. And S2 also is a causal LTI system with y of n equal to alpha y of n minus 1 plus beta w of n. The difference equation relating x of n and y of n is y of n is equal to minus 1 by 8 u of n minus 2 plus 3 by 4 y of n minus 1 plus x of n. So it is the total system, the cascade of these two systems. So they're asking us to determine alpha and beta and show the impulse response of the cascade connection of S1 and S2. So using this, we should find alpha and beta here, and we just need to solve this difference equations. Okay, first let us solve A. So you can see that we need to eliminate w of n and w of n minus 1 from these both equations. So what we'll do, we'll take this equation and we'll find w of n in terms of y. So it will be 1 by beta u of y of n minus alpha by beta y of n minus 1. Now I know w of n. I can substitute here. I also need w of n minus 1. So w of n minus 1 is nothing but 1 by beta y of n minus 1 minus alpha by beta y of n minus 2. So now I can substitute. So my w of n is equal to half w of n minus 1 plus x of n. So this is nothing but 1 by beta y of n minus alpha by beta y of n minus 1 is equal to 1 by 2 into 1 by beta y of n minus 1 minus alpha by beta y of n minus 2 plus x of n. So now if I only keep y of n here and take these both to the other side, because I want it in this format. So I'll get 1 by beta y of n is equal to alpha by beta y of n minus 1 plus 1 by 2 beta y of n minus 1 minus alpha by 2 beta y of n minus 2 plus x of n. Okay. So again, my left hand side, if you check out, it is of the form y of n. So beta also I should take to the other side. So I'll get alpha y of n minus 1 plus 1 by 2 y of n minus 1 minus alpha by 2 y of n minus 2 plus beta x of n. So now you can compare these both. Let me copy it down. So comparing these both, what you get? First you get beta is equal to 1. Comparing these both. And you can compare this and this. So you have minus alpha by 2 equal to minus 1 by 8. And your alpha is equal to 1 by 4. So you also need to cross verify this and this. So 1 by 4 plus 1 by 2 is nothing but 3 by 4. So this is also correct. So alpha and beta is going to be 1 by 4 and 1. That is what is the first subpart. And coming to the second subpart, show that the impulse response of the cascade connection of S1 and S2. So we need to solve this. So let me copy it down. So if you see, you have two terms here. So it may be difficult for you to solve. So one easy approach is to solve these both individually and then you take the convolution of them. Okay. So that will be an easier approach. Okay. So this is going to be nothing but y of n equal to alpha is 1 by 4 y of n minus 1 plus beta is 1 x of n. So this form you already know from the previous, I think we solved it previously, right? So this is for delta of n minus 1 x of n. But here we want to find the impulse response. So which means that your x of n is equal to delta of n. Or in general, we want the input of these to be x of n and then find the h1 of n and h2 of n. So then what will be this case? So let me solve for general case. W of n equal to a w of n minus 1 plus x of n. And your x of n is equal to delta of n. So your w of n is equal to 0 for n less than 0. So w of 0 for n greater than or equal to 0, we have this. So w of 0 is going to be a into w of minus 1 plus x of 0. So it is going to be equal to 1. Your w of 1 is equal to a into w of 0 plus x of 1. So it is going to be equal to a. W of 2 is going to be equal to a into w of 1 plus x of 2. These are again 0. This will be a square. Similarly, your w of n will be equal to a power n. Correct? So in general, what will be your w of n? So it will be a power n u of n. So similarly for S1, you will have h1 equal to 1 by 2 power n u of n. And for S2, you have h2 equal to h1 of n and h2 of n. 1 by 4 whole power n u of n, because your alpha is 1 by 4, right? So now we need the full impulse response, which is nothing but your h1 of n convolved with h2 of n. So this is going to be equal to summation k equal to minus infinity to infinity 1 by 2 power k, or let me write it in terms of h1 and h2 and then substitute it, h2 of n minus k. So this is equal to summation k equal to minus infinity to infinity 1 by 2 power k u of k. This is 1 by 4 power n minus k u of n minus k. So these two overlap will be for k greater than 0. It will be non-zero only for k greater than 0 and n minus k greater than 0, which implies that your k should be less than n, right? So your summation will be limited to 0 to n, 1 by 2 power k, 1 by 4 power n minus k. So here you can take your 1 by 4 outside. So what will you be left with? So 1 by 4 power n, summation k equal to 0 to n, and you will be 1 by 2 power k and 1 by 4 power minus k. So 1 by 4 power minus k is nothing but 4 power k. So this you can write it as 1 by 4 power n summation k equal to 0 to n 1 by 2 power k into 4 power k, which will give me 4 by 2 power k, and this is going nothing but 2 power k. So this summation is going to give me, so it will be a into r minus 1 by r power n minus 1 by r minus 1, and my a is 1 and r is 2. So what will by sum be? 2 power n minus 1 by 2 minus 1, which is nothing but 2 power n minus 1. So this is going to be equal to 1 by 4 power n. And we should not forget that here the number of terms is n plus 1. So n is equal to n plus 1. So this will be n plus 1. Right? So then it will be 1 by 4 power n into 2 power n plus 1 minus 1. So these are all the little things you need to take care of. All silly mistakes. So this will be nothing but 2 into 2 power n by 4 power n minus 1 by 4 power n. So this will be equal to 2 into 1 by 2 power n minus 1 by 4 power n. And this is only valid for n greater than 0, because you know that when two signals are convolved, and if they are for n1 less than 0, if there is one signal, and n2 less than 0, there is another signal, then their convolution also will be equal to 0 for n less than n1 plus n2. Here n1 and n2 are zeros. So this also is valid only for n greater than or equal to 0. And otherwise you can write h of n as 2 into 1 by 2 power n minus 1 by 4 power n u of n. Okay. So this is how you solve this question. Okay. Moving on, let us solve some gate questions. The impulse response h of n of a LTI system is given as h of n is equal to minus 2 root 2 for n equal to 1 comma minus 1, 4 root 2 for n equal to 2 comma minus 2, and 0 otherwise. If the input to the above system is the sequence e power j pi n by 4, then the output is. So your h of n, I can write in terms of delta function since it is only valid for 4 values. So it will be minus 2 root 2 delta of n plus 1 minus 2 root 2 delta of n minus 1 plus 4 root 2 delta of n plus 2 plus 4 root 2 delta of n minus 2. And my x of n is e power j pi n by 4. So my output will be convolution of these both. So h of n convolved with x of n. So this one is straightforward. You can write 2 root 2. You now need to replace n with n plus 1. So j pi n plus 1 by 4 minus 2 root 2 e power j pi n minus 1 by 4. Right? And then you have plus 4 root 2 e power j pi n plus 2 by 4 plus 4 root 2 e power j pi n minus 2 by 4. Right? So you can see that e power j pi n by 4 is common in everything, and 2 root 2 also you can take out. So you are left with minus 1 e power j pi by 4 minus 1 e power minus j pi by 4 plus 2 e power j pi 2 by 4 will be 2 plus 2 e power j minus j pi by 2. So each of them I can expand. So 2 root 2 e power j pi n by 4. So this is nothing but minus 2 cos pi by 4, right? And what will this be? Plus 4j sin pi by 2. Sorry, again this is also cos, right? So 4 cos pi by 2. Your cos pi by 2 is going to be equal to 0, right? So it will only remain with pi by 4. And pi by 4 is nothing but 1 by root 2. So this you can write as 2 root 2 e power j pi n by 4 into minus 2 into 1 by root 2. So this root 2 cancel, you will get minus 4 e power j pi n by 4. So the answer is option D. Right? Okay. So these are very easy to solve. Like you should just remember to use this delta functions. because your h of n is only non-zero for few values, right? You don't need to go for graphical method and solve. Okay. So coming to the second question, a discrete time linear shift invariant system. So instead of using time invariant, they have used shift invariant. So we should not get confused. So they both mean the same. As an impulse response h of n with h of 0 equal to 1, h of 1 equal to minus 1, and h of 2 equal to 2, and 0 otherwise. Okay. The system is given an input sequence x of n with x of 0 equal to x of 2 equal to 1, and 0 otherwise. The number of non-zero samples in the output sequence y of n and the value of y of 2 are respectively. So this one you have to calculate and only find. You can't use that concept of n less than n1 plus n2 plus 1. Why? Because you have this minus sign, which means that some of the terms might get cancelled. So this will only give you the utmost condition. It will not tell you the actual condition. So let us try to solve it. So your h of k is nothing but 1, minus 1 and 2. So 0, 1, 2. This is k. And your x of k is going to be 1 here and 1 for 2. So 0 and 2. 1 is at 1, it is 0, and everywhere else also it is 0. So now I need to find h of n minus k. So if I take h of minus k, this will go to minus 2. And if I do n, so this will be n minus 2, n minus 1, I'll have minus 1. And at n I'll have 1. So where I'll not find the overlap is your y of n equal to 0 for n less than 0 and n minus 2 greater than 2. So which implies that n greater than 4. So what are the values? N equal to 0, 1, 2, 3, 4. Alright. So let us try to find for each of them. So y of 0, what it will give me? So your n will be located at 0. So there will be one overlap, you will get 1. So y of 1 will be, just shift this to the right. So 0 into 1 plus 1 into minus 1 will give me minus 1. Y of 2 will give me 1 into 1 plus 2, minus 1 into 0 plus 2 into 1. So it is going to give me 3. And y of 3 will give me, so y of 3 meaning this will go to 1. So 0 into 2, 1 into minus 1, this will give me minus 1. And y of 4 will give me, only this and this will overlap, 2. Okay. So the number of non-zero values is 5. Right? And what else they have asked? They have asked for the value of y of 2. So your y of 2 is 3. So answer should be 5, 3. Option D. Okay. Moving on. A LTI system is defined by its impulse response h of n equal to 2 power n u of n minus 2. The system is stable and causal, causal but not stable, stable but not causal, unstable and non-causal. So what are the two conditions we need to check for? Causality is nothing but your h of n should be equal to 0 for n less than 0. So is it true here? So 2 power n u of n minus 2 is equal to 0 for n less than 0. And in general, specifically it is true for n less than 2. So it satisfies the condition. The system is causal. What about stability? Your summation h of n mod h of n from n equal to minus infinity to infinity should be less than infinity. Is it true here? So if you sum it up, it will come n equal to 2 to infinity, 2 power n. So this is clearly diverging. And it's equal to infinity because it is growing bigger and bigger. So the system is not stable. So the system is causal but not stable. Option B is the right answer. Okay, moving on. I think this is our last question. Let y of n denote the convolution of h of n and g of n, where h of n is equal to 1 by 2 power n u of n, and g of n is a causal sequence. if y of 0 is equal to 1 and y of 1 is equal to 1 by 2, then g of 1 equals. Okay, this is again a straightforward. So here h of k, or let me say I have g of k here. I have some g of 0, g of 1 and something else also. Okay, but one thing is it is causal, which means that these are going to be equal to 0. And I have my h of k, which is nothing but it starts from 1, then half, 1 by 4 and so on. So to get the convolution, I get h of n minus k. So where will it be? It will start from n, 1, and then half at n minus 1 and so on, right? 1 by 4 at n minus 2 and so on. So now my y of 0. So y of 0 is nothing but summation k equal to minus infinity to infinity g of k h of minus k, which means that this n will coincide with this. So which will give me g of 0 into h of 0 as the only valid signal, right? Valid sample. So this is nothing but g of 0 because h of 0 is 1. So this they have given us 1. So my g of 0 is going to be equal to 1. So I'll also plot it. So 1, this h of minus k of. So these samples are going to disappear because g of k is 0 there. So secondly, I will calculate h of 1 minus k, which is required for calculating y of n. So it will start from 1. At 0 it will be half. And 1 by 4 at minus 1 and so on. So what are my product terms? G of 1 into h of 0, right? Or I can write it as the value directly. Plus g of 0 into half. And this they have given us half. But g of 0 is nothing but 1. So my g of 1 plus half is equal to half, which implies that my g of 1 is equal to 0. So my right answer is option A. So these kind of questions are very interesting to solve, and we should also be very careful while solving not to make any mistakes. So try to solve as many questions as possible to get exposure and also find out where you are making mistakes and to not repeat the same mistakes in the examinations. Okay guys, so that's it for today. I'll meet you in the next video. Until then, take care. Bye-bye.